We are talking about inequalities in one triangle, and we want to recognize and apply the properties of inequalities to the measures of the angles of a triangle. And we want to recognize and apply the properties of inequalities to the relationships between the angles and the sides of a triangle. So we're looking at example 22. It says, find the possible range for the third side of a triangle with the lengths of two sides of the triangle are 4 inches and 6 inches. So we got to find out what the range is. Really, there's only two options here. 4 and 6 could be the small side, or 6 could be the large side, and 4 could be the small side with another example. So the two examples that we're gonna choose from. The first one is 6 is the large side. Okay. So if 6 is the large side, we want to say, from our example up here, a plus b, we don't want it to be equal to. We don't want it to be less than. We want a plus b to be greater than. So a plus b has to be greater than c. So basically in this place we said 6 is equal to c. So that means we can pick either, we'll just pick it as a. So 4 is going in as a. And then we want to solve for b. So how do we solve for b? We subtract 4 from both sides of the equal sign. Or both sides of the inequality sign. Our 4's cancel on the left, and we get b has to be greater than 2. Okay, so that was what we picked, that 6 was the large side, or 6 was equal to c. The other way we can pick it is the two small sides. So we can say that x is the largest side. Instead of saying that, we'll say 4 and 6 are the small side. Okay. So in that case, they would be a and b. So a plus b has to be greater than c. So let's put a as 4. Let's put b as 6, and that has to be greater than c. So 4 plus 6, so we get 10 has to be greater than c. So when we're writing an inequality, we always want to have the variable on the left side. So this is not correct. We want to put the variable on the left side. So c has to be less than 10. 10 is greater than c. C is less than 10. That's the same way. The pointy side is to the c. The pointy side is to the c. Well, is on the left. B is greater than 2. B is greater than 2. Okay. For this one, we want to be able to represent both variables. Instead of it as b and c, we want to be able to represent them as x. So x is greater than 2, and x has to be less than 10. So to write our compound inequality, we can put x in the middle. Which of these numbers is bigger, 10 or 2? 10 is the biggest. 10 goes to the right, just like we're counting on the number line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 2, and the x has to go in the middle. Now, pay attention to the direction the arrow is pointing. Is the arrow pointing towards the 2, or is the arrow pointing towards the x? The arrow is pointing towards the 2. So I'm going to keep the arrow pointing towards the 2. When we're comparing the x and the 10, is the arrow pointing towards the x, or is the arrow pointing towards the 10? The arrow is pointing to the x, so we're going to keep the arrow pointing to the x. So the possible numbers for the other side of this triangle has to be between 10 and 2. So that is the answer for this one. Now, let's think about what we really did here. And all this work, what did we actually do over here on the left? Well, we took the two sides and we just subtracted them. We just took 6 minus 4. So that was subtraction. And what do we do on this side? All this work, everything here, really all we did was we said 4 plus 6, or we had addition. So, given sides A and B, write an inequality to find the possible range for the third side C of a triangle. So what do we do first? All we did was subtraction. The two side lengths. Then what do we do next? We just did addition. Okay. If we want to write down the inequality, we could say that we have the two sides, the two small sides, A and B. The first one we did was we did subtraction. So that must be A minus B must be greater than C. Or, no, A minus B must be less than C. For subtraction, must be less than C. A minus B must be less than C. Or, the other way we could do it is we could say A and B, if we add those together, they must be greater than C.